All right, if you are getting ready for that CompTIA A+ Core 1 exam, you know storage is a huge topic. But there's one concept in there that can really make or break not just your understanding, but your actual data, and that's RAID. So today, let's crack that code.
So let me just ask you a question. Picture this. What happens when your most important hard drive, the one with all your critical files, your family photos, your entire operating system, what happens when it just dies? It's a horrible thought, right? All of that data could just be gone. Well, that absolute nightmare scenario is the entire reason RAID was even invented in the first place. You see, it's not some product you buy off a shelf. It's a strategy. It's a way to protect our precious data from a simple, unavoidable fact. All storage drives will fail eventually. So what exactly is RAID? It stands for Redundant Array of Independent Disks. And the core idea? It's actually brilliantly simple. You take a bunch of separate, independent hard drives, and you make them work together as a single team, as one logical unit. And depending on how you set that team up, you can get a massive speed boost, an incredible safety net for your data, or, hey, maybe even a little bit of both.
Okay, let's kick things off with the most basic level, RAID 0. If you're a gamer who needs lightning-fast load times or a video editor who's constantly wrestling with huge files, this one's for you. It is all about one thing and one thing only: pure, unadulterated speed.
The magic trick behind RAID 0 is a technique called striping. Now, just imagine you're dealing a deck of cards. Instead of putting them all in one big pile, you deal them out to two separate piles, one card at a time. It's way faster, right? Well, that is exactly what striping does with your data. It splits it up and writes it to multiple drives all at the same time.
And here's what that actually looks like. The system takes your data and splits it into blocks. So the odd-numbered blocks, 1, 3, 5, 7, they go to the first drive. And at the exact same time, the even blocks, 2, 4, 6, 8, go to the second drive. By writing to two drives at once, you literally double your performance.
So here's the trade-off, and listen up, because this is absolutely critical for the exam. You need at least 2 disks to make it work, and in return, you get that incredible speed. But, and this is a huge but, there's a massive drawback. You have absolutely no redundancy. And here is the single best exam tip you're going to get for this. The easiest way to remember RAID 0 is that RAID 0 offers 0 redundancy. Just think of that 0 as representing how much of your data you get back if one drive fails. Because all your data is split across the drives, if one of them goes down, the chain is broken, and the entire array is completely useless. All of your data is just gone. Now let's pivot to a completely different philosophy with RAID 1. If RAID 0 is the high-strung race car, RAID 1 is the armored truck. This has nothing to do with speed. This is all about keeping your data 100% safe. So RAID 1 uses a technique called mirroring. And it's exactly what it sounds like. Every single piece of data you write to that first drive is instantly, perfectly duplicated onto a second drive. It's like having a real-time, perfect photocopy of your entire hard drive. And it's always up to date. Okay, so let's look at the trade-offs here. Just like RAID 0, you need at least 2 disks. The huge benefit is full redundancy. If one drive completely dies, the other one just takes over instantly and you don't lose a single byte of data. The drawback, though, is pretty significant. You lose 50% of your total storage capacity. So if you have 2 1-terabyte drives, you only get 1 terabyte of usable space. And this, right here, is the fundamental choice you really have to understand for the A+ exam. Do you want speed or do you want safety? RAID 0 gives you that amazing performance, but if one drive fails, everything's gone. RAID 1 gives you a perfect real-time backup, but it's going to cost you half of your total storage. So we've got speed and we've got safety. But what if you want a little bit of both? What if you want redundancy, but you don't want to sacrifice so much storage space? Well, that brings us to RAID 5, which I like to call smart redundancy. RAID 5 is really clever. It stripes data across drives just like RAID 0, so you get good performance. But it adds a special twist, a little something called a parity block. Think of it like a simple math problem. If I tell you that 2 plus x equals 5, you can instantly figure out that x is 3, right? Parity works the same way. If one of your drives fails, that's the x. The system uses the data on the other drives plus that parity info to figure out exactly what was on the missing drive and rebuild it perfectly. Now, the key advantage of RAID 5 is just how efficient it is. It needs a minimum of 3 disks to work, but it gives you that awesome redundancy while only using the space of 1 disk for all that parity data, no matter how many more drives you add. The main drawback is that when a drive does fail, the system has to work pretty hard to rebuild the new one, and that can slow things down for a while. Okay, let's tackle a classic exam question. You're given 4 120GB drives, and you put them in a RAID 5 array. How much total space do you have to use? Just remember the rule. You always lose the capacity of 1 drive for parity. So, you have 4 drives, but only 3 of them are actually used for your data. 3 times 120 gigabytes gives you 360 gigabytes of usable space. I promise you, you're very likely to see a question just like that. But what if you need it all? What if you want the absolute maximum speed and the maximum redundancy, and maybe cost isn't your biggest worry? Well, that's where you find the top tier of RAID. RAID 10, often called the best of both worlds. The name RAID 10 is actually a huge hint. It's literally RAID 1 plus RAID 0. You build it in 2 simple steps. First, you create mirrored pairs of drives for safety. That's the RAID 1 part. Then, you take those complete mirrored sets and you stripe your data across them for insane speed. That's the RAID 0 part. What you end up with is what we call a stripe of mirrors. So, the bottom line with RAID 10 is, you really do get everything. You need at least 4 disks to even start. You get the blistering speed of striping combined with the totally bulletproof redundancy of mirroring. So what's the catch? Well, just like RAID 1, it's expensive. You still lose 50% of your total disk capacity to make those mirrors. Okay, deep breath. We've covered the core RAID levels you need to know. Now, let's boil all of that down into a final, rapid-fire review. Think of this as your exam day cram sheet. All right, this is the slide to screenshot, write down, memorize, whatever you got to do. Let's run through it. RAID 0, 2 disks, all about speed, and absolutely no fault tolerance. RAID 1, 2 disks, all about redundancy, yes on fault tolerance. RAID 5, 3 disks minimum, gives you efficient redundancy, yes on fault tolerance. And finally, RAID 10, needs 4 disks, gives you both speed and redundancy, and is absolutely fault tolerant. You are guaranteed to see troubleshooting questions on the A+ exam. So what are the telltale signs of a RAID failure? If you hear audible beeping alarms from a server, if you get an array missing error when you boot up, or if a drive just vanishes from your operating system, those are all massive red flags. You have to act fast because in a redundant array, 1 drive failure can sometimes lead to a second, and that's when you really lose data. And that brings us right back to the single most important thing you have to take away from all of this. If you remember nothing else, burn this into your brain. RAID 1, 5, and 10 are your safety nets. They provide redundancy. RAID 0 is the dangerous one. It offers absolutely no redundancy, and a single drive failure means total and complete data loss. Nailing that difference is absolutely vital for your A+ exam. Now go ace that test.